Hi, and welcome back. Today we're doing 5.2.2. How can I make it a perfect square? Our learning goals are one, that you will be able to rewrite a quadratic equation in perfect square form, and two, that you will be able to solve a quadratic equation by completing the square and then solving the resulting perfect square equation. We will be using algebra tiles today. There are electronic algebra tiles available to you. You can use the QR code from your notes or this bit.ly in case you can't see that. Well, I guess you have the notes though. Well, in any case, bit.ly/3 capital B 3 6 capital H capital Z lowercase. Okay, the first problem is 5-73. With your team, you're watching a video, so you don't have your team, but with your team, you're going to examine how the two different equations can be represented using algebra tiles as shown below. So let me get out the appropriate algebra tiles. 1, 2, and I need some 1. Okay, so on the left-hand side of my equation, I start out with 1x² tile. This is x squared because it's x by x, and this is x tile because it's x by 1. X, x, x. Okay. So this is what I have going for me at first. And then I have a 1. And I'm saying that in this situation, I have x² plus 4x plus 1 equals 0. Well, what happens if I add 3 to both sides of this equation? If I add 3 on the left-hand side, and I'm saying that this is equal to 0, and I add 3 here, 1, 2, 3, and I add 3 here, then I get x² plus 4x plus 4 equals 3. And the way I would write this would be x plus 2 times x plus 2. X plus 2 as a square equals 3. So what can we do that will result in this equation? Well, we can add 3 to both sides. And as you see, if I write x² plus 4x plus 4, which is this plus 3, and I factor that, I have 4x² on top, 4x on the bottom, 2x, 2x, and that factors to x plus 2 times x plus 2, or x plus 2 squared. Okay, part B. Changing the equation into perfect square form is also known as completing the square. This name is appropriate because its length equals its width. There are a million correct answers for this, but if we see this up here, this is an x plus 2 by x plus 2. And if you square it, you get x plus 2 squared equals 3. Okay. 5-74. Use what we learned in problem 5-73 to rewrite the quadratic equations below in perfect square form. Okay, so I'm going to go ahead and do that. For this first one, I have 1x squared, and I have 1, 2, 3, 4, 5, 6 x's. And I start out with, let's see, 1, 2, 3, 4, 5 ones, and it equals 0. Well, on the left-hand side of my equation, I'm going to need to add some number of ones. I need to add 1, 2, 3, 4 ones to make this a perfect square. And on the right-hand side, I'd better also add 4, because otherwise I violate equality. So if I add 4 on the left, I have to add 4 on the right of my equal sign. Okay, I'm going to draw that. So I started with x squared plus 4x and 4x. And over here I had 1, 2, 3, 4, 5. But 5 wasn't enough. I needed to add 4 more. So that becomes 9. Sorry, this should have been 3 and 3. I miscounted. I apologize. 9 right here. But in order to make this 9, I had to add 4 ones. So I have to add 4 to both sides of the equation. In an area model, that looks like x plus 3 by x plus 3, which is x plus 3 squared equals 4. Now, in this problem, I'm asked to solve the resulting quadratic equation. We did this in the last notes, but just to quickly review, we do that by taking the square root of both sides. Here I have x plus 3, and it equals plus or minus 4. The reason we have plus or minus 4 is because we don't know what x is going to be to make that true, and this becomes 2 different equations. I have x plus 3 equals positive 4, and I have x plus 3 equals negative 4. I solve each of these by subtracting 3 from both sides. I get that x is equal to negative 7. Can you read that? Yeah, let me read it again. Negative 7 or 1. That is an exact answer. And it turns out in this situation, the exact and approximate answers are actually the same. Negative 7 or 1. Okay. Next problem. Now, for this problem, I start having to deal with negatives. And since we're doing tiles, it gets just a little bit confusing. But in the video, red means negative. So I have 1 positive x squared is always positive, 1 of these, and then I have on each side 5 negatives, 2, 3, 4, 5. And in order to have this become a square, I need to add a certain amount to each side of the equation. Well, when I add a positive to a negative, it sort of becomes 0. So on this side, I'm going to add 1, and that will actually take a negative away for each of these negatives. So I add 1 and it takes the negative away. That's because -1 plus +1 is 0. I add 1 and it takes the negative away. I add 1 and it takes the negative away. I add 1 and it takes the negative away. And I keep going until I have a square. So this last one that I added is the one that made this a square. To solve this problem, I would have x squared plus 1x and 1x plus +1 equals 0 plus 6, which is the total I had to add to both sides in order for me to have the one that I need right here. So that gives me the equation x plus 1 squared equals 6. I take the square root of both sides to solve, and I get x plus 1 equals plus or minus the square root of 6. Now, in terms of exact equations, I can't do very much to this, except I need to subtract 1 from both sides. So I have two equations. X plus 1 equals positive the square root of 6. I subtract 1 from both sides. And x plus 1 equals negative of the square root of 6. And I subtract 1 from both sides. And my exact answer is the square root of 6 plus 1 and the square root of 6 minus 1. And honestly, that's the best I can do because this is the exact answer. But for the approximate answer, I can put the square root of 6, second square root 6 into my calculator, which gets me approximately 2.45, and I can add and subtract 1 from that. So I can say that x is approximately 3.45 and approximately 1.45. And that's that. Okay, next page. Yay! Okay, so now we're going to use algebra tiles to rewrite each of these equations. Here we have the very similar one. This is x squared plus 4x minus 5 equals 0. So I've got 1x squared. I have 4 x's. And I have 5 negatives. 1, 2, 3, 4, 5. And I'm going to go ahead and put these on a piece of paper, which will allow me to make an equation. Okay. So on the left-hand side here, I have the equation for this is where equality will be. X squared plus 4x minus 5 equals 0. So left-hand side, I have x squared plus 4x, all of these, minus 5 equals 0. And we're going to make a square. Okay. First, I try to make my square. I have this and this. Now, since these are positive, these values right here, I'm actually not going to be able to have any negatives. So I'm going to need to add a certain amount to both sides of my equation. In order to neutralize these 5 negatives, I'm going to need to add 5 ones to both sides of my equation. 1, 2, 3. Just getting some more piles. Oopsie, sorry. Okay. 4 and 5. Now, on this side of the equation, I've done -5 plus 5. So that goes to 0. So now I'm at +0. And on this side, I'm at +5. This is -5 plus +5. So this just equals 0. Okay, I'm not done yet. Now I need to make my little square. So since these go to 0, I'm actually going to remove this. And how many tiles do I need to make my square? So I need 1, 2, 3, 4. If I add 4 to this side of the equation, I'd better add 4 to both sides. 1, 2, 3, 4. In total now I've added 9 on this side. And I'm up to +4 on this side. Okay. So I have this square. This is x plus 1 plus 1 by x plus 1 plus 1. This is x plus 2 squared equals 9. Put it on our paper. We're going to make a drawing of a perfect square. I have x squared plus 2x plus 4 equals 9. X squared plus 4x plus 4 equals 9. And as a perfect square, that becomes x plus 2 squared equals 9. And then I can solve it. So I take the square root of both sides. I get x plus 2 equals plus or minus. The square root of 9 is doable. The square root of 9 is 3. I'm going to take the positive and negative version because I'm solving for x. This becomes 2 equations. X plus 2 is 3, and x plus 2 is -3. I subtract 2 from both sides, and I get x equals 1 or -5. This counts as both my exact and approximate version because there are no decimals anyway. Next problem. Okay, x squared minus 6x minus 1 equals 0. Here we go, yay! X squared scratch. I have x squared, -6x this time. -1, and it equals 0. Okay. So as a square, that becomes, my b term gets cut in half. That's interesting. Okay. -x squared, and I need to get to 0. Well, this will be the length -3 and -3. And when I square that, I still have to have positives. So I'm going to need to eliminate this negative by adding 1 to both sides. Now it's gone. And now I need to add enough little squares to make this complete. So 1, 2, 3, 4, 5, 7, 8, 9. Great. And this is the equation x minus 3 squared, because it's a square, equals 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Positive 10. Put it on our paper. So this is x squared, negative 3x, negative 3x, positive 9 equals 10. X minus 3 squared equals 10. That's because the semi-perimeter would be x minus 3 times x minus 3. Okay, now I solve my equation by taking the square root of both sides, which gives me two versions. X minus 3 equals positive square root of 10, and x minus 3 equals the negative square root of 10. From this side, I get x equals the square root of 10 plus 3, because I added 3 to both sides, or the square root of 10 minus 3. That's exact. If I want to make it approximate, which I do, I take the square root of 10, which is about 3.16, and I add that to 3, and I take 3 from it. So I get x is approximately 6.16 and 0.16. Okay. This one, I'm going to try to start talking into our algorithm. So if you notice, what I've been doing when I have this b, I take my b and I break it in half because I need it to be evenly spaced on each side of a square. So this would become x squared, and because I have two negative x's, I need to break that up, and I'm going to write it as, I'll draw it like this, negative x and negative x. Now, what I've been doing is I've been adding enough positive numbers to make this last term 0. So what I'm going to do here is I'm just going to do that right from the start. I add 3 to both sides. And you'll always do this. You want to move c, if you're in standard form, to the opposite side of the equation of your other term. So this becomes x squared minus 2x equals, I'm adding 3 to 1, so it's 4. Okay? Now, if I find the outside of this box, I can see what this little piece will have to be, how many squares I'm going to need. So it'll be a square of size 1. So this becomes 1, and that's what I have to add to both sides of my equation. So this is equals 5. But I've added 1 more to that side of the equation. If I write that in perfect square form, this is x minus 1 squared equals 5. Now I solve it. I have x minus 1 squared equals 5. I take the square root of both sides. That gets me x minus 1 equals the square root of 5, and x minus 1 equals the negative square root of 5. I add 1 to both sides, and I get x equals 1 plus the square root of 5 and 1 minus the square root of 5. Now the square root of 5 is approximately, I take the square root of 5, 2.24. So my approximate answers are x is about equal to 3.24, and, well, what's 1 minus that? Negative 1.24. Really? Very good. So here's my exact and approximate answers. Okay, we'll do the next problem in just a moment. Thank you very much. Okay, next problem. So this is 5-76. Use algebra tiles to rewrite 2x squared plus 12x plus 3 equals 11 in perfect square form. Then solve the resulting equation. Right away, I want to point out that the 2 in front of x squared is going to make things a little bit harder. So I prepared this whiteboard. See, can you see all of it? Okay. There. And this is the equation, 2x squared plus 12x plus 3 equals 11. There we go. All right. I have 2x squared. I have 12x's and 3 positive ones. And on this side, I have 11. I'm going to proceed as usual with a couple of changes. First of all, I noticed that when I have my square, I'm always, let me make it right now. I'm going to ignore the 3. I'm not going to be able to make a square right here. I'm going to actually have to make 2 squares, 2 separate squares. So instead of dividing by the 12 in 2, I'm going to divide it into 4 so that I can have 2 separate squares. Let's see. I think I like it more when the x squared is on top because that's how we draw area models. Yeah, like this. So this is going to be 2x squared plus 12x plus 3 equals 11. And the next thing I want to do to sort of just make things easier on myself is to get rid of this 3. I think it's like way easier to work when your c term from ax squared plus bx plus c is 0. Someone's knocking on the door. Be right back. Hi. Let me press pause and continue. Okay, so I'm going to press pause. Somebody's here. Just a second. So I'm going to subtract 3 from both sides of the equation. And what that looks like with algebra tiles is I just take them away, subtract 3. Bye. Goodbye, these 3. And on this side, I took 3 away, which leaves me with, good, I did it right. There are 8. Now this is 0 because I subtracted 3, and this is 8 because I took 3 away from 11. Okay, and now remember that my job is to complete the square. So in order to complete the square, well, I have to complete it. I have to take as many ones as it would take to make this complete. All right, here we go. This is going to be fun. All right, 1. I add 1 here, I add 1 here. 2, 3, 4, 5, 6. Oh, I already did 6. Hold on, how many do I have here? 8. I should have 8 plus 6. So 1, 2, 3, 4, 5, 6, 7, 8. And then I should have added 6, but I forgot. So I'm missing there. Good. We're on track. I think I need 3 more. 1, 2, 3. On both sides. 1, 2, 3. Very, very good. Okay, look, perfect. I could have predicted this was going to be 9 because I know that this is 3 wide. So I'm actually going to start to blend my algebra tiles with an area model by writing 9 here, plus 9, and plus 9. So what I end up with is 2 of these squares. I'm going to rewrite the equation. 2 of these squares are x by 3, so x plus 3 squared equals 8. How many do I have? 8, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. 17 plus 9 is 26. Okay, but you know it would be easier? Are you ready? I don't want this 2 here. This 2 is a lot of work for me when it comes time to doing equations later on. So what I'm going to do is I'm going to divide both sides by 2. On this side, it will look like taking away one of my big squares. And on this side, I'm going to break the 26 into 2 even pieces. So on one side, I'll have, let's see, I think I'm going to use squares instead of these 9. So I have to add 9 on. 5, 6, 7, 8, 9. All right, so I'm going to break this into 2 groups. 5, 6, 7, 8, 9. 5, 6, 7, 8, 9. Splitting it up. Okay. So what I have here is that one of these squares equals this many ones. And I'm just going to take one of them. So 5, 6, 7, 8, 9, 10, 11, 12, 13. So each of my x plus 3 squares equals 13. And I'm just going to get rid of the bottom part. And now I have a perfect square equation, and it's reduced. Okay, I'm going to write my results here. I'm going to make a drawing of my perfect square equation. The one that we finished with. So this is x squared plus 3x, 3x, and 9. I should zoom in again since I'm back to paper. Equals 13, which gets me x3, x3, x plus 3 squared equals 13. That's my equation written as a perfect square. X plus 3 squared equals 13. And I solve the equation by taking the square root of both sides. That gets me 2 equations. X plus 3 equals positive square root of 13, and x plus 3 equals the negative square root of 13. I subtract 3 from both sides, and I get my exact solutions, which is negative 3 plus the square root of 13, or negative 3 minus the square root of 13. For my approximate solutions, I will have to figure out the square root of 13. So I take 13. I get about 3.61. And I take negative 3 and I add that value, which gets me 0.61. And I take negative 3 and I subtract that value, which gets me negative 6.61. I have my exact and approximate solutions. So now that we've done this several times, what are you really going to do when you don't have algebra tiles? And you're going to take an equation and you're going to use an area model instead of algebra tiles. And there are 2 scenarios we need to think of. The first is when A is 1. At our level, that's what you're going to see more often. So for example, suppose we had the equation x squared plus 6x plus 5. Plus 4 equals negative 1. Here I have A equals 1, B equals 6, and C equals 4. Well, I don't want C to be 4. I want C to be 0. So the very first step is always to take your C term and move it to the other side of the equation. I'm going to do that by subtracting 4 from both sides of my equation. So that would get me minus 4 here, minus 4 here, and I have x squared plus 6x plus 0 equals -4. Now I make an area model. I take my x squared term and I put it right here. I take my b term and I break it into 2 even pieces. Here I have 6x, that breaks into 3x here and 3x here, just like on our area model. On our algebra tiles, when we would have had 6 x's, and that would have resulted in 3 of them being on one side and 3 of them being on the other, because of the fact we're trying to make a square which has the same length as width. Okay, then I try to find the outside of my box. Here I would have x plus 3 and x plus 3, and I complete my box by figuring out what needs to go down here, which would be plus 9. Now, keep in mind that I actually need to add 9 to both sides of my equation. So I had x squared plus 6x plus 0. Now I have x squared plus 6x plus 9. And I have to account for that by saying I had -5 on this side of the equation, but I have to add 9 to that, so it becomes +4. -5 plus 9 equals +4. This equation will allow me to write a perfect square form, because x squared plus 6x plus 9 is the same thing as x plus 3 squared equals, and then on the side of the equation we have 4, and this is a perfect square equation. The other scenario you might be faced with is when the number in front of x squared is not 1. And it's a little bit more complicated in that situation. So you have 3x squared plus 12x plus 6 equals 0. So for this last problem, the reason that it's sort of different than the other one is because the number in front of x squared right here is 3. When that happens, I want to sort of change the whole problem around and divide everything by 3, which is the same as multiplying by 1/3. And that gets me a new version of the problem. X squared plus 12 divided by 3, 4x plus 6 divided by 3, 2, equals 0 divided by 3 is still 0, so I have 0 here. Now, I'm going to subtract 2 from both sides, because I need to make sure that the constant term is isolated on one side of the equal sign. And that gets me x squared plus 4x equals -2. Now I'll take my x squared and my 4x, and I will behave as I have in the rest of this problem. X squared and 4x, 1, 2, 3, 4. Since I'm trying to make a square, I'll evenly distribute my x's. So I had 4, and now there's 2 on each side. X squared plus 2x plus 2x. That's splitting the x term in half. 4x goes to 2x and 2x. I split it in half exactly. Okay, now I can get the outside of my box. That's x plus 2 times x plus 2, but I'm missing this middle part. So to get that middle part, I need to figure out, okay, well, 2 times 2 is 4. But this 4 has to be accounted for when it comes to equality. So I just took x squared plus 4x plus nothing. That's just x squared plus 4x. And I added 4 1s. So if I'm going to add 4 1s right here, Well, then I have to make good and sure that the other side of my equation also has those 4 added on. So on the other side of my equation, I started with -2 because I subtracted 2 from both sides when I had just x squared plus 4x. And then when I add 4 to this side, on the right, I end up with just +2 because the negatives and the -2 plus +2 is 0. So this cancels and I'm left with just equals 2. So I added 4 to this side of the equation, that's these 4, and I added 4 to that side of the equation, that's -2 plus 2. -2 plus 4 equals 2. And that's how this is there. Now I can write my equation as x plus 2 squared equals 2. And you might think that we're done. And we kind of have made a square, not kind of, we made a square, but we have to deal with the fact that up here in the beginning, we divided by 3. So to fix that, you just go back in and you multiply this whole thing by 3. All the way across the equal sign. So this becomes 3 times x plus 2 squared equals 6. And that's your final answer. You might wonder how come we don't just leave the 3 gone, because if I were to solve this, I would get the same answers for both of these versions of the equation. And the answer has to do with something we're going to do in chapter 9, where we graph parabolas. And I don't want to lose the information of this 3 because when we get there, you'll start to see that that 3 makes a graph much more narrow. So that's why we still have to have that 3 there. Okay, thank you so much for your time. That's the lesson. Have a nice day. Bye.